Okay, well, in that case, good afternoon, everyone, and welcome to this meshwork webinar. Today, I am a guest host. My name is Nigel Banks. I'm Technical Director at Octopus Energy, and I am delighted to welcome Michael Barnard to today's webinar. And Michael, I think you're in Europe, in Antwerp, is that right?
I am. Tenant flew me in to help them assist them with 2050 scenario planning for their target grid. And I took the opportunity to travel northwestern Europe with my spouse for a month.
Fantastic. So the format for today's webinar is going to be what we probably describe as a fireside chat, but without the fire. And we won't have a formal presentation, but we'll have a conversation, and then we will open up for audience questions probably for the last 15, 20 minutes or so. So if you do have questions, please do raise them in the Q&A or the chat, and we will try and pick those up. We may pick them up on the way through. Otherwise, we'll definitely return to them at the end. So the topic of discussion today will be probably challenging for many in the audience, and it reflects an article which Michael recently wrote entitled "The Fabric First Trap: Decades of Studies Show Electrification Wins Every Time." And those who follow me on LinkedIn may have seen that I've written on this topic as well with an article entitled "Fabric Fifth." So I think me and Michael probably share some views on the topic, but probably come from quite different perspectives. And I'm sure there'll be some differences of opinion in the audience. So we do want that interaction later on. But we'll start with a two-way conversation. Um, and yeah, my plea is come with an open mind and listen to what we have to say, and then do challenge us at the end. So, Michael, perhaps to kick us off, can you give us a short introduction in your own words of your background and your sort of areas of expertise and the work you do currently?
Sure. I guess I'm probably best known for doing looking at major climate change problem areas, aviation, maritime shipping, uh, ground transportation, concrete, steel, hydrogen, and saying what are all the solutions and levers we'll pull to reduce those, which ones will be technically effective, which are actually technically viable, which ones are going to be cheapest and hence the ones that are going to dominate, and which ones will humans accept, and projecting that out through 2100. And so hence the pretentious title of climate futurist I kind of had to accept last year because that's what I'm doing.
What you're doing?
And so I help investors and organizations like Tenet to figure out where the ball will be instead of chasing the ball, saying that's where the ball's going, let's run there instead. And so I have clients around the world and I publish constantly because I can't help myself. Um, and yeah, so decarbonizing the building stock, existing and new, is part of my patch. And so I've looked at cross-laminated timber globally. I've looked at concrete and steel. I've looked at alternative. I've looked at reuse of buildings. And obviously, I've looked at providing heat to buildings for water and air.
Fantastic. And I think what I found really interesting is you sort of bring together economics, physics, which is often ignored by some in some of those topics, and but also the human behavior aspects. And what we've certainly seen is some transitions have been fairly slow and steady, but others have been really non-linear. And I think that has surprised some people. And I think before we perhaps go into the fabric first debate, it may be of interest perhaps for you to share uh, perhaps an example from a different sector where you've done some analysis and you feel you've definitely got that right, perhaps before others have seen that, and maybe something else that's perhaps surprised you, just to give people some context of the sort of areas of research you've done and how that's proven out to be often correct.
Perhaps even prescient, or at least I did the math and didn't buy into the narrative. Well, let's take hydrogen since I mentioned hydrogen, and and it was, Cadent and other UK organizations were attempting to shove the highly flammable square peg of hydrogen into the round hole of home heating, that round hole that comes with friction sparks like a matchbox, in an attempt to potentially kill people in the British Isles unnecessarily. I just think it was a hilarious attempt to preserve their molecular efforts. So I got lucky. Being a broad spectrum nerd who actually likes doing the math and likes looking at the numbers, Back in the late 2010s, when I was looking at hydrogen again in more detail, I started looking at the studies and I started assessing what it would take to make green hydrogen. And I did techno-economic workups in multiple places, including Northern Africa and stuff like that. And I realized hydrogen could be green, but it couldn't be cheap. You know,
Yeah,
making hydrogen required firmed electricity. Electrolyzers weren't going to get cheap nearly as fast as people thought they were. Then there was the 28 other components in an electrolysis factory that weren't cheap. And then storing, compressing, and distributing hydrogen wasn't cheap, was never going to be cheap. And I got lucky. I figured that out because I didn't buy into the narrative that green hydrogen was the answer. And I was just checking. I was asking the question. And so I realized that it was always going to be expensive back in 2018 or so when I was doing the math. And others like Joe Rom figured that out in 2004. And so now when everybody's starting to go, oh, green hydrogen isn't going to be cheap. And oh, BNAF triples its cost of expected cost of electrolyzers in 2050. And everybody's like starting to jack up their expectations to try to align. And they're still off, by the way. They're still only at 25 to 30% in their projections for 2024 prices. They're only still at 20 to 25% of the actual prices in 2024. And so now, as that entire hydrogen for energy, including home heating and commercial heating, bubble deflates and pops, and thankfully didn't kill anybody in the process, I can say I told you so with a gleeful bit of Schadenfreude in my voice.
fantastic. And maybe something that surprised you that you've gone, oh, that's gone faster than I thought. The costs have changed. Other than sort of solar battery, I think probably most people know. Is there anything that's you gone, oh, that's interesting?
Uh, yeah, solar in Pakistan, because I look globally.
Yeah,
I don't have a patch except the world, and I don't have a domain except everything that hits climate change. And so
fantastic.
by the way, folks, when I speak about climate change and home heating and stuff like that, I don't care about comfort. I don't care if people have to put on a jumper. As long as they're not freezing to death or dying of heat prostration, I consider that adequate for my social requirements. I care about the climate change aspects of it. Your clients, on the other hand, are going to care a lot about comfort. So please understand that when I'm speaking from a climate change perspective. But back to the solar in Pakistan, they put in 17 gigawatts of rooftop solar in 2024, bringing their total solar to 22 gigawatts of solar.
So that's
And it was
more.
all because
Yeah,
that's all
that's
just
more.
because it was cheap,
Yeah,
you know,
that's
and they could
more
just,
than the UK's got in its entirety was installed in
yes.
Pakistan last year. Yeah,
And 5 times as much as Canada does. Where, I'm a Canadian, just by the way. I'm traveling Europe from North America as a Canadian.
okay, not the
My
other North
watch has
American.
the Canadian flag on it.
Okay, fantastic. So hopefully I wanted to ask that because I think it's interesting for those that you're coming definitely from a climate change perspective, but also a very uh, well, top down and bottom up. What's the cost? What's the practicalities? What's the realism around some of this? And so perhaps onto your article, The Fabric First Trap. Give us a brief summary of the sort of thesis that's in there, and maybe why did you feel you needed to write this?
Okay, well, the passive house people and the people who are really advocates, I've bumped up against them before, and they've really got up my nose. So this is why I felt I had to go back and look again, because every time I've been asserting for probably 5 years that I don't care if people have high home heating bills as long as they're running on electricity and electricity is green, because from a climate perspective, good enough. If people in Texas want to have houses made of doilies and just be put in massive walls of fans, but as long as they're running off of clean electricity, from a climate perspective, we don't really care. There's some secondary systemic concerns about how much energy is consumed and how much we have to provide at different times of year. But those are secondary concerns. The primary concern is decarbonizing home and residential and commercial heat. And that's heat pumps are the answer for 90% of that. District heating, where that's viable, not Texas, except maybe 2 blocks of Austin. Um, or a campus somewhere. But so my thesis has always been, well, you've got to electrify, and then you do the fabric stuff in a Pareto optimization. You just do enough fabric to help the budget balance out. Um, and of course, every time I say this, a bunch of passive house types, and one of whom I eventually had to, remove from my social media circles on LinkedIn because he just refused to not be argumentative about this, what appears to me a really obvious thing. Um, because he's just invested in the passive house thing and his professional stuff is invested there. And so they just keep hammering me with what I thought were irrelevant arguments to my thesis. And to be clear, once again, I'm not a practitioner in the space. I'm not dealing with a client, and I'm not dealing with a situation where people are really uncomfortable in a home and want to be comfortable. That's not my concern. And I'm not dismissing those concerns. I'm just saying from a climate perspective, they're somewhat irrelevant as long as people aren't freezing to death or dying of heat prostration in their homes.
Yeah. But you called this the fabric first trap, and I think that relates to sort of rebound effects. And I think you pointed to various international studies that have been done on that. So perhaps just pull out a couple of those highlights
Sure.
of
Well, I'll just go through all of them. I've got a nice summary list here. Thank you,
okay.
Chat GPT. I asked it to summarize my article on the subject.
Good.
And so I've had this discussion with Jan Rousnow Jan Rousnow of the, well, still with RAP, but now with, a great position in the UK. Because he had challenged me on something. I've always been talking about the UK study from 2023. I think it was, where was it?
Cambridge. Yeah.
Yeah, the Cambridge study, which basically looked at 55,000 UK houses that had had insulation and governmental funding. They looked at gas stuff, and eventually all the gas rebounded. So there was zero gas savings in those 55,000 houses. And he said, well, it's a bit more nuanced than that. And I have a lot of time for Jan. So I said, oh, okay. How is it more nuanced? And are there other studies on this? Because one study is a data point, a a big chunk of studies from multiple countries. Oh, well, maybe that's not just a data point. Maybe this is. And so I went and I looked at the UK, which already had the warm front study from 2011, which found that there were some minor savings, but mostly it was eroded by comfort taking. People were in homes that were leaky. They were wearing jumpers in the wintertime, and they turned up the heat. They opened the windows. They got fresh air, and they were warm enough, and gas just went back to neutral. And so they're spending exactly the same amount of energy. We're having exactly the same climate change methane emissions from the leakage of the distribution system for methane, which is very big. It's not just burning the natural gas in a furnace, it's all the leakage along the way and all the slippage of methane from furnaces and from stoves. Basically, it leaks out of the pipes, it leaks out of the furnace, it leaks out of the stoves, and methane is a really high global warming potential gas, 80 times that of carbon dioxide over 20 years. And so this is a concern, right? I mean, it's a big thing for me to roll up those gas networks in order to get rid of all that gas burning and all that methane leakage. And people telling me, no, just leave the gas in, just insulate, just really got up my nose. So 2011, warm front, Wales, 2017, 37% initial gas reduction eroded by the rebound effect. So still only 37%. We want 100%. We
We've got
want
to get to 100% in buildings. Yeah, absolutely.
Germany, 2021, 340 billion spent on retrofits, no net national heating with gas reduction. Once again, rebound back to exactly the same gas consumption. USA 2018, Fowley et al. 10 to 20% persistent savings, and that was it. And that was far below the model 25 to 50%. A feature of these studies finds that the projected savings in gas never materialize, and frequently there are no savings in gas at all. New Zealand, another one, 2007. We're back 2 decades now. Moderate energy savings, all reduced because they turned up the heat. And I did digital walk arounds. I did digital nomading in New Zealand a couple of years ago. They don't have home heat in many buildings, So it was really odd to me that they actually had a study that did this, and they have no insulation. They have the worst building code in the world. It's just hilarious. France, 2024. Um, this starts getting to the ones that actually did more sophisticated assessments, and they said, okay, so let's do replacement, let's do insulation and electrification and compare. And the French study from 2024 from ERL found a 19% savings from insulation alone and 81% from electrification from the grid. And that was just electrification. And then the USA study 2023, LBNL and Brattle, 90% emission cuts were possible with targeted insulation and electrification. You do the minimum amount of insulation required to achieve the business case to right size the heat pump. You know,
Yeah.
so we that's study after study for 2 decades, which finds exactly the same thing. It's not fabric first, and we fabric first is the wrong mantra. It's not fabric fifth, I don't think, which is very productive and cheeky title you used. But fabric first is a trap. If we insist on regulation for fabric first, if we insist as practitioners on fabric first, we're doing no favors from a climate change perspective. And last, I'm just going to say this really clearly. When I was talking to the head of the Global Carbon Project, Rob Jackson, he cut his teeth on indoor air pollution studies on gas stoves and furnaces. And the indoor air pollution from gas stoves was off the hook. Never mind comfort.
Yeah.
Gas appliances make kids sick and make adults sick. So no climate value, no health value, and all you're doing is you're not getting any, you're just making people a bit more comfortable and not helping them. So I just hate this fabric first thing, and people are resistant to getting electrification in there. So that's me. I'm a bit irate about this.
And I
This is
think
me irate. I'm a Canadian. I'm sorry.
and I think the fabric where I got to with fabric fifth was a frustration that a lot of the government programs at the time required insulation before you fitted a heat pump,
Oh
and
yeah.
that meant that some people uh, didn't get a heat pump because they didn't want to empty their loft to get loft insulation or wait 3 months for someone to drill some holes to fill the cavity when they had a boiler that needed replacing urgently. And hence I put the electrification first, combined with smart tariffs to bring down running costs and grid impacts. But I do think there is value in doing some basic fabric interventions. I don't think you're saying never insulate, but you're
No.
saying do the basics to enable cost-effective electrification. Um, and I think
Slight nuance there.
yeah,
Once again, I remember I said if you live in Texas and you want to build a house of doilies and just throw green electricity at it all day long and all night long, I don't care from a climate perspective. Um, what we have to do is, from a governmental policy and regulation perspective, which you got to, is not require fabric first before enabling electrification, because electrification is the climate solution. If people want to overpay for a heat pump, why would we stop them? As long as they're decarbonizing, because electrification is the climate answer, not insulation.
okay. Well, I'm going to come back to a few challenges on that because I've had a lot of challenges on some of these points that
Yep.
I've raised. But I just wanted to flag a couple other data points really on the discussion. One was the analysis by UCL on the London housing stock that definitely pointed to a similar sort of point that insulation alone will not decarbonize the housing stock. I think that's pretty clear.
Yep.
And it's electrification that delivers the carbon savings. And interestingly, the Committee on Climate Change, or the Climate Change Committee, it's now called, in their latest Carbon Budget 7 report that was out last month, I think. In the previous carbon budget report, they had 250,000 solid wall installations a year. In the latest analysis, they've updated that and they've now said instead of 250,000 a year, they've just got 15,000 full stop before 2050 of solid wall insulation and no floor insulation. And that's because they have looked at it from a pure technical economic analysis perspective to say what do you need to achieve net zero in the most cost effective way. And they found 15,000 of the 7 million solid wall properties in the UK would need some form of solid wall insulation to allow that electrification cost effectively. And I think that's probably where you've got large, remote, rural properties that would need a significant grid upgrade to the electrical infrastructure to bring it. The fabric insulation may bring you onto a single phase and not require big electrical upgrades. So I think there are some small scenarios that from a techno-economic analysis, there may be some properties does make sense to do some more deep interventions.
Well,
It seems to be
let's test that because
okay.
it's great that the UK is doing this very data centric empirical oriented thing. But I think there's some organization or company that says you can put batteries and solar panels with heat pumps on remote rural properties and not have to upgrade. Do you know anything about that?
So, so yeah, look, solar and battery is absolute. In fact, that's the bit for me around heat pumps deliver decarbonisation, solar battery and some low cost insulation measures deliver significant bill savings. But solar and battery is the one that delivers the biggest bill savings. But I think if there is a challenge with startup currents on heat pumps that if you require a 25 kilowatt thermal heat pump, you currently need a three-phase supply, is the current guidance around that. And you would need a huge amount of solar battery to bring that down to be able to run that heat pump in a winter cold, worst case, cold, snowy condition. So I think you can use solar battery to help, but on a dark Christmas night in the north of Scotland in the Cairngorms, I suspect the solar is not going to help very much, and you may need your heating on fairly continuously if it's -5 outside. So I think there are probably some examples, but I think it is very niche. I think for 99% of homes, and that's what the analysis from the Climate Change Committee says, is that is more of a they kind of, well, in my view, they agree that fabric first is no longer the piece. So in your article, you also talk about this sort of anchoring bias, and I think one of the things that I've seen is there are people that have looked at the data, analysed it, and come on board. Interestingly, the Passive House Trust in the UK have got a new retrofit guide which does talk about installing heat pumps and low cost measures ahead of deep retrofit. So they have, I think, as an organisation in the UK, moved a bit. Um, but yeah, that anchoring bias, that's pretty strong, and I guess you see that in many sectors. And
Yeah, so I did mention that I kind of do the three analyses, will humans accept it? And that means I spent a lot of time on cognitive science. I haven't worked with, I never got a chance to work with Daniel Kahneman, but I have worked with a bunch of people who work directly with them. And, kind of like 1 degree of separation, because some of my content is in Bent Flugebjerg's book, How Big Things Get Done. And Bent Flugebjerg, I ran across first in Daniel Kahneman's Thinking Fast and Slow.
mm,
So, and I've spent a fair amount of time with Ben and his team. Um, but there's a few cognitive biases in there. There's just stuff that make us human, and I'm subject to them too. Everybody is. Kahneman, I just love Kahneman's intro. He says,
I think we might have frozen
Yeah,
Michael.
Michael's frozen. Hopefully he will come back.
I think I was about to say something quite profound as
He
well.
was, he was indeed. He really
best thought
was.
of as something you can
Oh,
see in
Michael,
the case of.
we lost you. You were just about to go into. If we lost the last sort of 30 seconds or so.
Okay, so Daniel Kahneman is great in his intro to the book, Thinking Fast and Slow, because he says, I don't claim to be not have psychological biases. I have all of them, and I can't spot them in myself. Think of the book as something for water cooler conversation to recognize biases in others to try and correct them systemically. Um, and so one of them is confirmation bias. If you believe something, like if, for example, and I'm just going to say, if, for example, if you built a third of the passive houses in the UK, it would be very difficult for you to overcome that with data that showed otherwise. And so congratulations to you for overcoming that, because that was tough. Um, you know, you
Yeah.
know, the stuff that we hold to be true, we deprecate data and sources which go against that quite substantially. And we anything which supports our bias, even if it's a crap article in a clickbait news headline that includes, flammable vinyl siding, we'll go, oh yes, of course that's true because I believe it. Subject to it, subject to it. So confirmation bias is a big one, but the anchoring bias is another. The anchoring bias says, here's where we started. And so it's very hard to move from that number. So all the studies make it clear that the assumptions about how much benefit would be achieved vastly outstated the actual benefits resulting. But we kept doing. We've got decades of studies, and the data was there to be looked at, but it's hard for us to move off that number. I'll go back to hydrogen as an example. As I say, I got lucky on that one. Well, who didn't get lucky? The International Energy Association, LUT, Australia's CSIRO, they all said, as far as I can tell psychologically, green hydrogen is necessary for decarbonization. What price point does it have to be at delivered in order for it to be economically viable? Okay, let's all pretend we can achieve that.
Yeah.
And then let's twist our math to support that. And so in 2020, they had estimates of the cost for manufacturing green hydrogen that were radically out of sync with 2020. And then in 2021, they all inched up their estimates slightly. And so in 2021, they're radically out from the actual results. And in 2022, they inched up slightly. In 2023, they inched up slightly. That's the anchoring bias in action. We don't move to where the data says the reality is. We move our anchor slightly towards that. And so that happens with our assumptions about insulation. And it's difficult to let go of that and do a radical retrofit. BNEF, the Bloomberg New Energy Finance, actually tripled its price point for electrolyzers in 2050, the only one which did a radical change. And the interesting thing is, I think they're still wrong. I think they're still too low. But that's okay. At least they took a leap as opposed to a caterpillar inch.
And I think that confirmation bias and the anchoring bias, I think, is also exacerbated by social media. So the people you follow on LinkedIn or Twitter or Blue Sky, whatever it may be, will be repeating those messages, and that's sort of thing. Oh, well, there's another person that thinks the same, and I think that's an interesting challenge. And I think you mentioned some of the early projects I was involved with. At the same time as being involved in the first 30 of the first 100 passive house projects in the UK, I was also involved in the first 100, the first 120 zero carbon housing projects, which included solar, included heat pumps and heat networks, and were more technology led. And that perhaps gave me a broader perspective on the benefits of each. And the other thing which I've got very into now working at Optimus Energy is understanding the energy market and the importance that and the benefits that the ability to move when you use your energy can bring with flexible smart tariffs. And it's very interesting when we're talking to developers or house builders, and many on the audience may well see or experience this themselves. Those who've got an electric car or have got a solar and battery system at home and can see and feel those benefits on their bills become a lot more engaged and easier to have a discussion around those technologies than those that have just focused in on their one area. And I think I think that's an interesting point. So we've got we're going to open up for questions in about 10 minutes. So I think I've seen one or two points in the chat. So do fire some more questions in. But perhaps we can come back to some of the points that people challenge this against fabric first. So the first one is around, won't we need a grid that's twice the size, and doesn't that cost more than the cost of the insulation? What's your take, or have you had any sort of looks into the issues around sort of grid constraints? The argument originally in the UK was we use, I think it's 120 gigawatts worth of gas on a peak winter's day, and we've got a 30 gigawatt grid. How does that translate? And we're electrifying heat, we're electrifying transport, we're going to electrify other things. By not doing insulation measures, we're going to have to build a bigger grid. What's your sort of view on that?
Okay. Well, so let's start with heat pumps only require a third of the energy, a third of the gigawatts to provide the same heat because it's drawing heat from the environment. Fundamental efficiency. We're using electricity for work, which it's really good at, to move heat from one place to another. And so that means we don't need 120 gigawatts of electricity for heat. We need 40 gigawatts. Oh, that's more than the grid currently supplies. Completely agree. But then we can say, oh, well, we also need the cars and stuff like that. But just as people will charge their cars in the middle of the night with a timer, if you send a price signal, there's ways to move electricity demand around as well. Got to remember the grid is built for absolute peak electricity demand. Everybody in the UK is in one time zone. They all get home at 5:30 or 6. They all turn on the telly, turn up the air conditioning, or turn up the heat. They all put on the bossa nova, whatever it is they do. Energy consumption spikes, you
Yeah.
know, and many of them now are just plugging their electric cars in without concern for peak energy demand because they don't care, and they don't have smart chargers. But that's not what has to happen. So let's just take midday when in the UK, when even in the wintertime, there's incoming solar radiation and sunshine hitting the grid. And somebody's drilling in the hotel somewhere near me. So
No, we've got you. So we can't hear the background noise. We're all good.
you can't hear the background noise. Oh, that's
No.
so good to hear because it's really annoying to me. The noise canceling headphones are actually doing what they're supposed to do. They used to not do that. Okay, so just just as anybody who has an EV now, in the wintertime, they pick up their phone and they go, tap, warm this to 18 or 19 degrees before I get in.
Yeah.
And then they walk out 10 minutes later and they get in a nice toasty car that's not been running. It's not been burning gasoline and idling. It's just been taking electrons and turning them into heat for comfort. Same thing. Uh, Heat pumps can be on a timer, and at 3 p.m. when electricity is cheap, they can warm the residence. And so you can actually have a nice toasty residence before you get home, even after you've cut off the stuff. But that's not all you can do. My favorite example is, it's a stupid, simple hack, but it works, which is thermal storage. And water is a great thermal storage mechanism. My favorite is Harvest Thermal, now just Harvest, under Dr. Jane Mellier, who I talked to a couple of years ago. She basically puts in something that's like a water tank, has 4 times the volume, which means not that much bigger because you're increasing the cylinders, you're increasing a 3-dimensional space with limited amount of external increase in volume. But it gets 4 times the water, and she drips hot water in when electricity is heat. So the top is hot and has a thermocline and it's cold on the bottom.
Yeah.
And so you can pull cold water, you can pull hot water, you can pull heat for underfloor heating or radiators, or you can do heat exchange for blowing heat. And it works on an AI that says, when is electricity cheap and how much is this family going to demand over the next 2 days? And then it makes sure there's enough heat and hot water to fulfill demand the most cheap way possible. And that flattens demand. Same way as having the timer on your EV, puts it at 3 a.m., flattens demand. The grid doesn't actually have to increase in size. It goes from a spike of 90% or 95% at 6 or 7 p.m.
Yep.
to the same peak, but 60% across 24 hours. And so your grid actually doesn't have to expand substantially. You did point out that a heat pump has a high draw. It might have to go to a better grid connection. But even there, for a lot of the stuff, because you can have batteries, you can have solar, there's ways to increase that. You can also put batteries on far more rooftops. I mean, I was in the Netherlands. The Netherlands blew my mind. It has more rooftop solar than Australia on average.
Yeah, and they don't put 2 panels on the roof. They're putting 20 panels on the roof. It's the whole
And
roof.
well, they don't even, the roofs I saw, they weren't even filling them, but they were still putting enough to make a big difference.
Yeah.
And
That's
so,
interesting. And I think to point people to some other analysis on this, the National Energy System Regulator, what was National Grid, publishes an annual future energy scenario for the UK. And this week they published their 2025 scenario. And they do look at different scenarios of different levels of electrification of heat and do talk about peak grid impacts. And previously there's been quite a lot on insulation. There is still some stuff on insulation in there, but the biggest impact they talk about now is shifting loads, and they call it sort of heat demand flex. So flexing when that heat demand happens, flexing also with electric vehicles when that happens. And we have that tariff, which is half the price between 4 and 7 in the morning, between 1 and 4 in the afternoon, and between I think it's 10 and 12 at night, so that you can heat all your hot water for half the price of normal electricity and do almost all of your heating year round at half the price, because that's the period when energy is cheap and when people want to heat their houses. And another study, if people are interested, the Centre for Net Zero, which is an independent R&D arm that's supported by Octopus Energy, but has access to our data because it's within our group, so it can see all our smart meter data. They monitored a tranche of homes where they turned the heating off for 2 hours, and these were existing homes in the UK without high levels of insulation or fabric. And actually, for 2 hours, the temperature difference was, I think, on average, zero point 0.3 or zero point 0.4 degrees Celsius. So that basically that you wouldn't notice, your thermostat wouldn't doesn't actually kick in for an hour or two. So the ability to turn off heat pumps for an hour or two in the middle of winter at peak time isn't a problem from a comfort perspective either. So I think there is a growing evidence base around that. I think the bit which I haven't seen hard financial numbers is what's the financial impact of that. But I just the reason I wrote the Fabric Fifth article was I'd seen some government funded programs spending over £100,000 putting 250 to 300 mils of insulation on the outside of a one bedroom flat, costing £100,000. And because they had to extend the roof, then had to dig out the foundations to deal with the thermal bridging. And yeah, and I heard yesterday of a project funded under the current Warm Homes Fund where over £200,000 is being spent on the fabric upgrades of a house, which is mind-boggling. You could rebuild a house much more cost effectively than that, and effectively that's what some of these projects are doing, are rebuilding a house on the outside of the house. And counter to that, the cost of installing heat pumps, solar and storage that deliver massive cost savings and delivers decarbonisation is yeah, an order of magnitude less now than in some cases.
And to be clear, while I deprecate comfort, which our audience can't, because if they don't make their clients comfortable, the clients will not hire them and will not recommend them. But it delivers comfort as well.
Yeah. Yeah, that was the last piece around comfort and health. You talked about the health impact of gas, and I think clearly burning gas inside a kitchen, often without very good ventilation, is not a very good idea for health. And you mentioned the hydrogen safety issue, and I think there's still a significant safety issue with gas, natural gas, and the amount.
4,000 buildings a year in the United States catch fire or explode due to natural gas.
Yeah, I think the UK stats are something like 17 deaths or serious injuries a year. Um, so this is this. So there is definitely other benefits of electrification. But I put fabric fifth because I felt if people still have the money and want to do the work to improve
Oh,
their comfort, then why not? But my main message was around don't let that be the last step. Make it the last step, not the first step.
yeah.
So I think we'll open up to a few questions, and I've got a few that I wanted to ask if others don't. So I think there's a
Pick the most
question
irate
about
one first.
the most irate one first. Nuclear. That's often one which is
Completely
a challenging
completely
piece.
unrelated to this topic. If you really want me to go off topic, I'll tell you
All
why
right.
nuclear is a
I
bad
think
idea.
you think nuclear is a bad idea. Okay, let's keep it short and sweet. Demolition versus. I mean, I talked about it would be cheaper often demolish and rebuild, but from a carbon perspective, you said you looked at steel, concrete, CLT, etc. Um, what would your view be around what local authorities should require? Should they require people to retain buildings and still electrify, or promote demolition and rebuild from a climate perspective?
Oh, retain the buildings, renovate wherever possible, unless the building is demolished, the foundation is crap. A building has to be in pretty bad shape to, for it not to be worth from a climate perspective, for rebuilding to be the better answer.
Yeah, and I think even CLT has a significant upfront carbon footprint, and the
But it
trees
doesn't
that are
have to.
but the trees that are
To be
planted take time to recover the carbon. If you start from
Depends on the
today,
argument. So cross-laminated timber. So the argument I make is we can electrify forestry, we can electrify sawmills, we can electrify distribution of the panels, we can electrify the construction equipment, and every ton of CLT, cross-laminated timber, embodies a ton of CO2 from the atmosphere. I count that. The standards organizations globally are arguing about whether to count that or not because of the end of life. But I argue I've got 5 different mechanisms for preserving that sequestered carbon dioxide from the atmosphere that I'm personally aware of. And that means there's probably 15 because I know stuff, but I don't know everything. I am not omniscient. I'm not the flying spaghetti monster. Um, and so I think that sequestering a ton of CO2 from the air should be capped for 80 years, should count.
okay. I think currently, I don't think you deliver those savings, but there is
No, but
definitely
you don't deliver 100% from heat pumps. But we know that we're moving towards fully electrified, fully decarbonized electricity. So every year a heat pump gets better.
yeah,
Same argument. We have a movement in a direction. The direction that helps us is cross-laminated timber, not continuing with concrete and steel.
interesting. There's been a question around if there's a question around nano coatings and nanothermal sprays, which I've always been slightly dubious around their actual performance from. I haven't seen any positive analysis from independent sources around them. But in the eventuality that insulation was a technology came along that made insulation super cheap, your argument still stands that it doesn't deliver the decarbonisation. So even if it was
No,
if it was free, you might reduce your demand by 50%, but you still got 50% gas if you're still on gas or oil or etc. Because I
and
think
you've still got the methane leakage all the way along the supply chain, the methane leakage inside the house, and you've got the nitrous oxides that create smog, which cause asthma in children inside the house, as well as other, slightly less common chemicals which cause other health impacts. It's, cooking with gas. I got to say, the natural gas, they won on so many different marketing things. Natural gas. It's not whale gas. It's natural gas. Oh, that's just an accidental marketing win. Natural. It's natural. Even now. Oh, it's natural. And then cooking with gas, that entire marketing campaign to make us think that burning the stuff inside our homes was superior. Induction, baby. Induction.
very good. So Jay Clayton was asking around. On Fabric Fifth, we had heat pumps were number one, smart controls and smart tariffs number two. I had basic ventilation and fabric measures at three, and solar and storage delivering cost reductions ahead of fabric interventions. So that was the Fabric Fifth list. Phase change materials, thermal battery storage. So you talked about the benefits uh, of hot water storage. I presume you haven't got any view around phase change any different other
Oh,
than
sure I do.
is it cost effective, or what's your take on that?
I haven't seen anybody use pencil it in as cost effective. It gets talked about a lot, but reality is, it's cheap to build a big store of water or to use an underground aquifer as a thermal store. And I was in the Netherlands where there's 1,000 seasonal thermal storage systems that just go down to underground aquifers, pump heat down in the summertime, pull it back with heat pumps in the wintertime, and it works and it's cheap. And the thing is, a phase change material is a very expensive material compared to a vat of water with some insulation that's buried.
Yeah.
So you can build a very big vat of water and get a lot more heat storage or a vat of sand in the case of some of the sand batteries and stuff like that. But if you want heat, the cheapest material possible that delivers the heat is the one you want. The phase change material advantage that people talk about is it can be engineered to return heat at a specific temperature. So you can get it to emit constantly for hours at 20 degrees Celsius. The thing is, that's what heat pumps and temperature controls are for.
Yeah, I think I mean, there's a company called Sunamp based in Scotland that have got a relatively cost-effective solution, and I think the main benefit that they and the main use case they promote is the size and shape factor that they can achieve, where often in our very small British homes there isn't much space for a hot water cylinder, and that is a use case which I've seen, and but
Sure.
there are new solutions I'd say that people are developing that will fit uh, in existing spaces as well that will store some water or use heat exchangers and heat pumps directly, which is interesting. Um, Gas price is 8p while electricity is 28p. And so heat pumps don't save any money, I think is the gist of that. And if
Yeah.
you have badly insulated homes, that isn't the case. So I've definitely got a view on that, but where's your take on that?
My view is that in the UK, electricity prices are bound to gas prices, just as they are in most of Europe. The problem isn't electricity prices. The problem is the tying of electricity prices to gas prices. You've got to decouple that, got to reduce the spark spread. You've got to reduce, well, let's just take Germany as an example. Germany had equivalent uplift on gas and electricity and other fossil fuels by a ratio, but it was just a very expensive for electricity, and it was expensive for gas because they're promoting efficiency. But they could get rid of that uplift on electricity, promote electrification, and now for industrial heat, they've dropped their industrial electricity price from 15 euro cents to 6 euro cents. Now that's reduced the spark gap per BTU. And I can use BTU because you guys are a bunch of Brits, so you
We
probably
don't
know what
use
the BTU
BTUs.
is.
We don't use
Oh yeah,
BTUs anymore.
sure. The UK, and what I think is hilarious is the United States does. I just love razzing the UK, the United States types. But per gigajoule, it's actually cheaper to get heat from electricity in Germany for industrial heat than it is from natural gas now. And everybody in the world realized how fragile the economic value merit of natural gas was. We'd had 20 years of consistently low prices for natural gas and stability of natural gas because of the fracking boom. Or guess what? The Permian Basin and the other basins, they're at the last third of sites, and they're all of a sudden at marginal value propositions, they're going to start declining rapidly because they won't be able to make money on shale and natural gas. Their entire LNG thing, LNG remains the most expensive energy that any country can import, and it can be displaced massively by solar and wind, domestic solar, wind, and storage. So it's going to be. So gas prices are going to get spikier and more volatile as we move forward. And so the stability of electricity prices, as long as we decouple from the stupidity of gas by building renewable storage and transmission, means that we're going to end up with stable prices. But a policy and regulatory requirement is to reverse that spark gap so that people don't end up paying 3 times as much for electricity. Now, to be clear, 8p for gas, well, with a heat pump, that's not 24p for electricity. Oh, it's 8p for electricity as well because heat pumps are 3 times as efficient. So
Yeah.
there is a spark gap even now with heat pumps in the UK because of the stupidity of tying electricity prices to gas prices. That's going to go away. Everybody's aware of it. It's coming. It's not here yet. It's very annoying that it's not here yet.
And I think that's one of the things that we're certainly pushing government hard on. The Committee on Climate Change has also flagged in their carbon budget is the biggest thing we can do to help decarbonisation for households and household and electric vehicles as well, and transport is reduce that electricity price, which is artificially high with levies and taxes and charges that are on electricity or not on gas. And that came from a legacy of it was only 2012 when we had 40% coal powered electricity in the UK. But yeah, you talked about the facts. The facts have changed, and we need to change our views as a result. So we talked quite a bit about insulation. Yeah. What about air tightness improvements? Any perspective on that? I presume it's the same argument.
If
Doesn't
it's
deliver
cheap and it
decarbonisation.
helps the business case for a heat pump, sure. I like what the UK has done, which is they removed the regulation, removed the requirement for fabric improvements before heat pump grants are awarded, but they still recommend improvements.
Yeah.
But that's a recommendation. It doesn't block a heat pump. It doesn't require stupid stuff, especially the ones, to your point, that required whatever the grading system in your country is. It's all different in multiple countries. But there you had to be an A grade in order to be able to get a heat pump grant. And people were at like G grades and they're like $100,000. But who cares, right? Electrify. And so the fab air tightness, it's good. As long as you have heat exchangers, once again, if it's airtight and you don't have heat exchangers and you have gas inside, then you have a buildup of those natural gases inside the house. So you can actually be increasing indoor smog and increasing health impacts unless you're doing that. So air tightness is an interesting subject with a double-edged sword. If it's cheap and you do the right ventilation with heat exchange, sure, fill your boots.
Yeah, and I think the perspective around importance of ventilation, build tight and ventilate right is another fabric first style phrase that's quoted in construction a lot, and I think that there is no harm in building well and building airtight. I would still come back to the cost and the energy involved to get to extreme levels of air tightness, and requiring mechanical ventilation with heat recovery in all homes, which was a proposal put forward to the government and hasn't been adopted. Uh, I think is the right approach. I've been involved in quite a few projects, passive house and non, where the fan usage for ventilation has been very high. The people haven't changed the filters on their ventilation units, and they haven't been particularly well fitted, and the noise requirements meant people have turned them off, and therefore their only means of ventilation, well, they have got generally got opening windows, but often in high rise they haven't got opening windows. Then you have a very sealed building with people not knowing the impacts of turning off that ventilation. And I think that's one of the things we're probably not very well educated on the benefits of ventilation in the UK, and the health impacts and the performance impacts of poor ventilation are really significant. And I think that links to Shane's question around mold growth, which um, has become a really significant issue, and there's been some very sad deaths that have occurred directly linked to mold growth in homes in the UK. Um, and but there has it has come up that in some cases has been a result of an unintended consequence of poorly fitted insulation, creating trapping moisture in walls, or even in other situations, insulation there's been something difficult to insulate round, and so people have left it, and that creates a cold spot, and all the moisture then collects on the inside of that cold spot, creating a source for damp and mold growth, which once it starts is quite hard to deal with and get rid of. But again,
I understand in the UK you just burn down high rises in that case. Oh, wait, that was something else.
so we insulation and making sure that insulation is done well. And that's one of the reasons the cost of insulation has gone up significantly is we have moved from large using petrochemical insulation products on low-rise housing to now using mineral wool, and only using mineral wool on high-rise buildings. And that has had uh, yeah, I mean that has driven up the cost because there's limited amounts of that insulation available, and well, there's probably been some profiteering from various parts of the industry to make if demand is high, prices go up, and that's one
Shocked,
of the
color me
reasons the
shocked.
installation cost has gone up massively. So it used to be £10,000 a house to do insulation. I think we're now probably near £30,000-40,000 pounds, and at the same time, it used to be £30,000-40,000 to fit a solar battery, and we're now down at £8,000 a solar battery. So that they flipped the costs. As well. So let's do one last question, quick one. When might we expect to see companies expanding their zero bills homes offerings to include EVs and modern vehicle to home? So That's a great question, Phil. That'd be a nice way of finishing off from our perspective at Octopus. We are doing zero build homes in new build, and that is um, combining basic building regulations, fabric performance with solar battery heat pump, and that includes and you can get to a zero energy build very cost effectively. If you've got a vehicle to grid car, and there are some now available, and you can buy them through Octopus as well, you can get up to, I think it's 12,000 miles of charging for free as well. So you can now buy a home and a car that is with no energy bills, and that is the enormous um, improvement we've got in bringing together the power of the cost-effective technologies with the smart control and the tariff to unlock that. So I think that's a really exciting future and creates a really positive uh, way for people to want to engage in electrification, because electrification can be cheaper, can be better, can be safer, can be better for your health, and I think promoting the carbon arguments is often difficult, and that's one of the reasons we talk about zero bills homes. They're effectively zero carbon homes, but it's much zero bills is a much better, more engaging customer proposition.
Plant.
I definitely did not plan that question, but it was a very nice way to finish that off. Is there anything you want to finish off or plug yourself, Michael?
No, I don't work in the building trades. I don't build high-end homes, and it's not like any of your people on your the call are going to be engaging me at my outrageous rates to assist them with investment advice for billion-dollar infrastructure funds. So,
You never know.
I never know.
But what I would say is you have a fantastic podcast, Redefining Tech. Uh,
If you're a nerd, it's a nerd cast. So anybody who goes in there expecting not to get nerd blasted on multiple topics. Yeah,
But yeah, if you're interested in some of those other sectors, you just done one recently on geothermal, one recently on maritime. If you're interested in other sectors and some of that stuff, it is a very thoughtful and often challenging to the convention that many people have in their brains as to what the answers to some of these big challenges we face are. So I will wrap up there. Thank you very much, Michael, for joining us. I've enjoyed the conversation. Hopefully, people listening in and watching on YouTube in the future will do as well. Thanks for the comments in the chat, and I will pass on to Simon to close us up.
Thank you very much, guys. Or should be coming back onto camera. I'll stop recording. No, here we go.